Mommy, I don't. You can't talk.
All right, hi guys. We are going to post some videos in the next couple of days and weeks for you to watch that are on some topics that we haven't been able to get to yet this year, but that you're probably going to be exposed to on the PSSAs. So we want to review them and make sure that you remember them from 3rd grade and from things we've done from earlier in the year before then. So the first one is symmetry, and I think if we said symmetry to you, most of you would be able to remember that symmetry means that we can fold something in a way that allows two parts to match up identically. So if you look at the images right now on the screen, in figure A, they folded a piece of square paper, of rectangle paper there down the middle, and then folded it in half, and it would line up like you were making a card for someone. That left-hand side would line up exactly with the right-hand side, so that when we fold it over, we would end up with these sides, with these sides matching there, right along here, so we would end up with a single figure half the size.
There would be nothing like hanging over the edge or nothing not lining up. It would all be equal.
Mommy,
The same thing they did
Mommy.
they did the same thing with the bottom one. They just folded it in the other direction. So another line of symmetry would go this way. So a rectangle has two lines of symmetry we can see there. A line of symmetry is where we fold the paper, and then being symmetric is the fact that we line up. So if we look at some different shapes, we can look at the square as having lines of symmetry. We can look at a diamond, oh, not that one because I didn't draw it right, as having lines of symmetry. A circle would have an infinite number of lines of symmetry because we can fold in lots of different places and have that fold in half evenly. Then there's a lot of shapes we get into that may not have lines of symmetry. So if we were to look at something like some special triangles, you're not going to be able to fold that in any way where you're going to get even parts matching up. So that triangle is not going to have any lines of symmetry. So what we're going to work on is identifying shapes that have symmetry, how to find that symmetry, and then what do we do with shapes that have no lines of symmetry.
All right, if we look at these pictures, these are examples. So I like this first one. It's a heart. So basically what you have to look at is the line of where the line of symmetry is. So if you look at a heart and if you were to draw a line straight down the middle, and if you folded both sides over, it would look like this, and it would be symmetrical because nothing would be hanging out. There's one line of symmetry. These are like some special crazy designs, but they still all are symmetrical. If you, right here is the line of symmetry for this shape. If you cut this down the middle, this side would match up perfectly with this side. This one actually has two lines of symmetry. If we cut it down the middle this way, this side would line up with that side. Or you could cut it this way, and this side would line up with this side. Oh, no, it wouldn't. I lied. Because look at it. Right here doesn't match right here. So I'm lied about this one. This one actually has one line of symmetry. This side with this side. This shape right here, here is this line of symmetry. This top half would line up perfectly with this bottom half. Some shapes can have one line of symmetry, and some shapes can have multiple lines of symmetry, like the rectangle one. Remember, here's one line of symmetry. This side would match this side. Or we could cut it this way, and this side could match this side. There are multiple lines of symmetry.
All right. What we're going to do really more in 4th grade is look at shapes that we're familiar with. So looking at things like pentagons and hexagons and octagons and seeing if they have lines of symmetry. So they have a hexagon up here on the board for us, which means a 6-sided figure. And they've drawn some different lines of symmetry there. You can see there's a line of symmetry through line A and through line B, because if we fold those, our sides are going to end up matching up exactly. We have the same shape and space on that side as we have there, and same here. This is another point in which we can fold and end up with matching identical sides. If you look at C, C is not going to fold our item in half identically, because do you see how this side is very long and this side is very short? And then same over here, I have a short side here and a long side here. So when I fold those over, I'm not going to be able to match that mirror image on the other side. Same with line D. Line D is not a point of symmetry because, again, I'm not cutting that shape in half evenly. I have long and short, which means that when we fold in half, they're not going to be able to cover each other in that exact way. The other thing we're going to get into is some more complex shapes. So you'll be looking at shapes that have, like multiple points to them, and looking to see if you have more than one. So we have one line of symmetry through the middle. If you turn that shape, can you find any other points of symmetry? And in this example, we're not going to get one. But if we were looking at, for instance, an octagon, we could end up with multiple points of symmetry as we turn and rotate that shape. Through each of our point-to-point or line-to-line, we're going to end up with another line of symmetry there. So you have to consistently turn the shape to see if you can get multiple points.
There to there, that would, or there to there, that would. So the points are important.
So right on those points are what we call vertices, where those two line segments meet. You're going to get lines of symmetry through each of those, and then you're also going to get lines of symmetry through the exact middle of each side.
This is our last thing. So this is looking at some different shapes, and you're going to have to look and see which lines are symmetrical. So I'm going to start line AB, because that looks symmetrical. I'm looking at it. I'm like, oh yeah, that looks like it's in the middle. So line AB, and I write AB and a line over it, and that means line AB. D and C, what do you guys think about that one? I think that looks symmetrical, so I would write line D, E. Ooh, FE, look at this side's that short and this side's really long, so F and E would not be a symmetrical line. Number 2 has this shape, and if I were thinking about it, if I cut it in half this way, that doesn't make sense because even though it's halfway through the shape, this has this little thing right here and this side doesn't. So that's not going to work out. So line IJ is not symmetrical, but line GH is symmetrical because this side would match this side. Oops. Okay. We have 2 more. We have a star. If we're looking at a star, line MN, let's think. If we fold this over, this would be symmetrical because this would line up over here and that would line up here. So line MN is. However, if we look at, if I turn my head, I'm kind of like turning my head to rotate it. KL. I think that one also
It's
might
still
be
symmetry.
symmetrical.
Yep.
Yeah, even though it's turned the same way, because a star, KL, if you turn it, if you rotate it, it still has
And
the
that's
same
the
symmetry.
thing about symmetry is if you could see Miss Johnson and I right now, we're turning our head to the left and turning our head to the right. Or if you have the object in front of you on paper, you can actually just turn the paper clockwise around in a circle. Because what you really have to do, K and L is not obvious to us right off the bat the way M and N is. Because our eyes are playing tricks on us. We have to reorient ourselves sideways and make sure that does indeed make a line of symmetry or does not by twisting that shape or twisting our head.
The last one is an oval, which is not, like we said, a circle has an infinite amount because it's the same on each side. This is an oval, this is a little different because one side is shorter and one side's longer. If I look at line ST, I know that that is symmetrical because this side would cover this side exactly. If I looked at the next one, let's do line OP right here. That is also symmetrical because the top half would line up perfectly with the bottom half. And then the last one is QR. This one's tricky, even though it's going down the side. If you think about it, if you took this side and folded it over, it wouldn't line up with this side right here because this half, it's not in the middle of the circle.
It's not curving in the same arc.
So OQR would not be symmetrical lines. So this shape has 2 lines of symmetry. This shape has 1 line of symmetry. Number 3, the star, has 2 lines of symmetry. And number 4 has 2 lines of symmetry. Okay?
All right. So the plan is that you're going to watch these videos over the next couple of weeks and do some additional practice when you get to class. So when you watch the video and you think you're ready to quiz out of symmetry because you've done this review online, come see us. You'll take a quick 2-point quiz and you'll be done with symmetry.
All right. Keep an eye out for the next couple of videos.